So today we are going to start for vibration analysis. We are going to find out the mode shapes. ठीक है, तो मॉड शेप्स बेसिकली क्या है? मॉड शेप्स निकालने के लिए वी आर गोइंग फॉर नेचुरल फ्रीक्वेंसी. उसके लिए जो प्रॉब्लम हमने लिया है दैट विल बी फॉर अ बीम. ओके, वी आर गोइंग टू डू मॉडल एनालिसिस ऑफ अ बीम. ओके, इट्स गोइंग टू बी फिक्स्ड फ्रॉम वन एंड. सो उसके लिए वी आर गोइंग टू नीड टू थिंग्स. वन इज योर स्टैटिक स्ट्रक्चरल, okay, or directly you can take model. Okay, this is your model analysis. So double click on this. So that same thing, it's going to be for finding out the natural frequency. So यहाँ पे basically first of all we have to decide our material. Okay, so double click on that material. We need that structural steel, and if you want to edit these isotropic properties, no, we can change that. But right now exactly whatever that product is already given, these properties are okay for my product. Okay, so I'll move to that modeling part again. Now what we need to create? We need to create a geometry. So here basically we can see there are two options. So it's basically two modeling space. You can do modeling there. Okay, so I'm going to work on that new design modeler for that geometry. Now that modeling window is going to open separately. So there you can do that modeling. You can create sketch, जो भी मर्जी आप करना चाहो वहाँ पे मॉडल्स आप बना सकते हो. सो दिस इज बेसिकली योर मॉडल विंडो, डिज़ाइन मॉडलर. ओके, सो फर्स्ट ऑफ ऑल हमें अपने यूनिट्स चेंज करने हैं इसमें. ओके, सो वी आर गोइंग टू चेंज आवर यूनिट फ्रॉम हेयर. मिलीमीटर ले लेंगे यहाँ से. उसके बाद मेरी ज्योमेट्री का जो साइज़ है दैट लेंथ इज़ 250, दैट हाइट इज़ 250 एंड क्रॉस सेक्शन इज़ 25 mm by 25 mm. ओके, रेक्टेंगुलर क्रॉस सेक्शन इट इज़. सो क्या करेंगे, हम एक्स वाई प्लेन को सिलेक्ट करेंगे, राइट क्लिक करेंगे, लुक एट दैट एक्स वाई प्लेन इज गोइंग टू बी इन फ्रंट ऑफ अस. यू कैन सी दिस कोऑर्डिनेट्स. तो उसके बाद स्केच में जाना है. वी विल टेक दैट रेक्टेंगल फ्रॉम हेयर. वी कैन स्टार्ट इट फ्रॉम दिस एंड एंड वी विल क्रिएट अ रेक्टेंगल. ओके, नाउ वी नीड टू गिव द डायमेंशंस. सो गो इन द डायमेंशंस and just click on this horizontal and vertical dimensions. So we know that is 25, your height is 25, horizontal distance is 25 and vertical distance is also 25 mm. Okay, so just click here. Now my geometry is ready. Now we need to convert it to 3D model and give a height of 250 mm. So just click here on that extrusion. After that already that material geometry is selected. If the geometry is not selected, then you can go here and select the sketch. After that just apply over here. Now you can see here when we have clicked on this, one sketch has been selected. Okay, that rectangle has been selected. Now what we need to give? We need to give the height, that is 250 mm. Okay, the beam height is 250 mm. So need to click here, and after that you need to generate. Now right click and you can see the isometric view. So this is my beam. So we need to close this modeler window. You can close, either you can minimize it to move to that another module. Okay, so this is your mesh part where you are going to see the model analysis. Okay, so just double click on this model analysis. A separate mechanical window is going to open for that. उसमें basically आपको vibration analysis, model analysis से related you will get that complete tools. Okay, so that we can analyze the vibration analysis over there. We can get that natural frequencies. तो यहाँ पे आप देखोगे तो you will find here this is your model window is going to open. So model analysis window is going to be open. So we are going to create a mesh over here. Right click, generate a general mesh first. So this is quite large mesh, that element size is quite bigger. So what we are going to do, just click on that mesh again, and below here you can see there is an element size. So element size is basically that line you can see between the vertices, that is the length. So you can give 4 mm over here. You can see that unit you need to check, that is in mm. Okay, so again you are going to right click on mesh and generate mesh. So you can see now it is a fine mesh. Now you can even check the number of nodes and elements if you are going to click on this statistics, you can see 15,000 nodes are there and 3,000 elements are there. Even you can basically increase these numbers by reducing the element size. Okay, as you are going to increase or decrease the element size, that computational time is going to increase or decrease. Okay, so we have done that mesh. Now we need to click on that model analysis. Okay, after clicking on that model analysis, what we need to do? Okay, first thing is going to be, obviously we need to give a support. Okay, there is a fixed support, so I'll take that fixed support over here, and from here we are going to click on that face. Just click on this face and apply the support. Okay, the support has been applied. Now what we need to find out over here is going to be your pre-stressed. Okay, you need to click on that analysis setting. So how much mode shapes you want? Okay, these are that number. This is given 6, just like I want more. You can just click here and increase it by, or you can write like I want 25. Okay, so that 25 natural frequencies you are going to find out over there. Okay, so after that, what do you need to do? Just go on that solution. Right click and solve. Now after that solution is going to come, you are going to see various mode shapes over here. Okay, so these are 25 mode shapes, and here you can see that frequency in hertz. Okay, so from 1 to 25, you can see obviously it's going to be varying. Okay, so here what I need to do is, if I want to see these 25 mode shapes, you need to click on this surface, right click over here, select all, right click again, and what we need to do, create a mode shape results. Okay, just click here. Now you will see here 25 different mode shapes are going to come. Okay, now what we need to do, right click over here and evaluate the results. Now we can see the different mode shapes. Okay, so at mode shape 1, we are just going to click. You can see that is going to show that bending. Okay, so when you are going to play, you will able to see the bending. Okay, it's going to show you the bending one. Now if you are going to go for that deformation 2, now if you are going to check, it's going to be compressive. Okay, it's going inside. So different mode shapes are going to give you different shapes, and if just like if I want to click here and then I'm going to check, it's going to twist. Okay, so these are various mode shapes on different natural frequencies we are going to get. Okay,